Yeah, you can start.
So good evening everyone. I am Mukesh from second year CSCI department, and in today's open mic session we'll be seeing the topic Introduction to Kubernetes. So today's agenda will be as follows. First we'll see about Docker and containers. So it is important to know about it in order to know about Kubernetes. And next we'll see what is Kubernetes, and also we'll see what is the need for using it. And finally we will show a demo application how to deploy a web application with Kubernetes. So let us start with Dockers and containers. So Dockers is a platform as a service. It is a platform as a service which uses OS level virtualization to deliver software in packages called containers. So basically Docker is a toolkit. So with that only we are building the containers. So it is used to separate the applications from the infrastructure, and it can be so that it can be delivered very faster. So Docker basically uses a client server architecture, and this client will communicate with the Docker daemon using the APIs. With the help of this, it will try to run, build, and distribute this Docker containers. So what this container is? So container is nothing but it is a basic template only. So it is a standard unit of this software, which contains all the packages, packed up codes, and the dependencies required for running this application. So with the help of these containers, we can run in different OS environments. And these containers are basically like a lightweight, loosely coupled, and standalone templates, so that it can be run in different OS environments. So with the help of the Docker, we will be building the containers, and these containers will be including everything that we need to run an application in an isolated environment. So container application is like highly preferred because of its portability, and we can like if you are building an application, you want your friend to run it, you can use this Docker so that it will be like portable, and it also independent of the platform where you run it. So now let us see like what's the key difference between the containers and virtual machines. So containers are basically isolated and lightweight component, and it runs an application on the host operating system itself. But in virtual machine, we'll be having guest operating system. So each application will be running on different guest operating systems, and these guest operating systems will be having separate kernel and memory resources allocated to it. So it is resource intensive. And one key difference is that the virtual machines will virtualize the entire machine till the hardware layer. But in container, it will only virtualize until the software layer just above the OS level. So this is the key difference between a container and a virtual machine. And one important advantage of container is it reduces management overhead, so that the resources will be distributed evenly to each application. And when we are trying to modify an application, it will take a lot of time in virtual machines when compared to the containers. So usually these virtual machines take a lot of storage space, but the containers will automatically manage and allocate the storage and the resources required for each application which is running in the environment. So these are the like a key difference between the containers and virtual machines. So now let us enter into the main topic, that is nothing but Kubernetes. So since like Kubernetes is nothing but is just a portable and scalable open source platform for managing containerized applications. So it was originally developed by Google, and it was released to the public in the year 2014. But they were extensively using this Kubernetes in Google like before 2014 itself. But it became available to public on the year 2014, and from then it was managed by the CNCF Foundation. So basically, Kubernetes is nothing but it is like a orchestration platform which will automate the manual process involved in, like it will automate the deployment, managing, and scaling of this containerized application. So when coming to a production environment, we need to manage these containers, and we need to run this application and make sure that there is no downtime. So for example, let us take if a container, if one of the container goes down, and if another container, then what this Kubernetes will do means it will automatically open up another container and it will be start running it. So in this situation, Kubernetes is really helpful. So now let us understand like what problem this Kubernetes solves. So for example, let us say that we are having a web application and we need to deploy it. So initially there will be like only few number of user or client, let us say around 5 to 10 users. So in such situation, we need only single web server. So it will take care of all the resources and need for the like 5 to 10 clients, you can say. But like when the number of users increases, we need to scale our application. So it is nothing but we need to like introduce more number of servers to handle the more number of clients. So this is where the Kubernetes will help us. What it does means it will be helping in managing the resources required, and it also creates a container for each web application, and it will try to run in it. So in here, like there's another terminology involved, which is nothing but pods. Pods are nothing but it is the smallest unit in execution. So in what it contains means it will be containing one or more containers in it. So like whenever there is a need for scaling the application, we will be using this Kubernetes. So now let us see the Kubernetes architecture. So Kubernetes mainly consists of two important components. One is the control plane, which is also called as a master node, and another one is the worker nodes. So this control plane, what it will do means it will manage all the worker nodes, and the inside the worker node we can see the pods present in it. So this worker node, what it will have means it will be containing these pods, and within the pods there are like one or more containers in it. So coming to this control plane, we can see that there are like four components inside it. One is the API server, scheduler, controller manager, and etcd. So let us see each component one by one. So usually what happens in control plane is it uses like API to communicate with the worker nodes. So this is taken care of the API server component. And there will be also a special scheduler which will take care of like creating and managing new pods in the worker node. And next one is the control manager. So this control manager, what it will do means it will be controlling all the controller process, like a creation of node, a job, and a token controllers. And finally, we are having the etcd. So what it is nothing but it's like a database only. It will be storing distributed key value stores, and it will manage all the metadata of these worker nodes. Now let us see the components in the worker node. So in the first layer, like we can see in the first layer, there are two components. One is kubelet and another one is kubeproxy. So kubelet is nothing but it's like an user agent. What it will do is for each worker node, it will make sure that the containers are running properly inside the pod. And next one is the kubeproxy. So what it does means it is basically a network proxy, and it maintains the network connections and forwarding traffics within the nodes. So in the second layer, if you see means we will be having the container runtime. So Docker is one of the popular container runtime. So and in Kubernetes there's an alternative container runtime which is known as CRI-O. So since Docker is popular, we are making use of it extensively. And in the final layer, we will be having pods in it. This pods it is nothing but is the smallest unit in Kubernetes. So what it contains means it will be containing only the like one or more containers in it. So now let us see why do we need the Kubernetes. So like there are few services and facilities offered by this Kubernetes. So let us see one by one. The first one is the service discovery and load balancing. So Kubernetes can expose a container using this DNS name or their own IP address. So if we can say that if a traffic to a container is very high means this Kubernetes will be taking care of the load balance, and it will distribute this network traffic along the deployment. So next one is the automated rollouts and rollbacks. So we can automate Kubernetes to create like new containers for the application deployment, and we can remove the existing container and transfer all the resources to new container using this Kubernetes. So like we can with the help of this we can quickly move to another version. So, and next point is automatic bin packing. So we can tell how Kubernetes, we can tell Kubernetes to use only this much of CPU and memory for each of the containers, container application. So what it does means it will be creating containers, and it will be we will be mentioning the CPU and memory usage, and it will try to make the best usage of the resources we provide. And next point is the self-healing. So what in here what happens means the Kubernetes will automatically restart the containers which will fail or which will stop from running, and it will replace them with new containers. So like if any containers stopped means it will be replacing, it will be creating a new container, and it will move the existing application to the new container. And finally we have the secret and configuration management. So what it does means it will Kubernetes help us when storing managing sensitive information like password and OAuth tokens. So we can say we can you can deploy and update the secret keys and configuration without rebuilding the container itself. Let us say if we change the OAuth keys or password, so we don't need to again deploy it from the starting. It will automatically rebuild itself without deploying from the starting point. So these are the important features provided by Kubernetes. And Docker also has another orchestration tool called Docker Swarm. But Kubernetes is widely used because of the following features which I have mentioned in this slide. So let us see where this Docker and Kubernetes fits into the DevOps lifecycle. So we can clearly see that where Docker and Kubernetes take place in this lifecycle. Docker is mainly used in the deployment phase of the developing applications. So we can build and deploy this container using the Docker after the completion of the coding and testing phases. But coming to the Kubernetes, it is in the operational phase of the development cycle. So take us of the automatic deployment, scaling, and management of these container applications. So now let us see some demo of how to deploy web applications in Kubernetes. So currently I am having a web application which is nothing but a health board. It is a demo application. So what I'm going to do is I've already installed a Minikube and a kubectl. So what is Minikube is? It is nothing but it's a lightweight Kubernetes implementation. So in local system, if you want to run Kubernetes means you can use this Minikube. And kubectl, it is nothing but it's a command line interface tool. So with the kubectl commands, we can run and deploy and build Kubernetes projects. So let us see this is the health board I'm having. This is a web application. So first what I have done is I have created an image for this web application using the Docker file. So I already created an image. Now in order to create and deploy this web application in the Kubernetes, we need to mention a YAML file. So this is the YAML file. And in YAML file, I am having two components. First one is the deployment configuration, and second one is the service configuration. So let us see this deployment configuration. So this deployment configuration will be basically having the version numbers and what kind. This is since it is deployment configuration, we are mentioning it as deployment. And also there is metadata of the name of the application. So I am giving it as my app itself. And here I have mentioned the image of the container. So this container is already published in the Docker registry. So this is the name I have given. So here from here only it will take the image that is container image, and it will be trying to deploy this from this image. And next one, let us see the service file. So service configuration. So in service configuration, we'll be mentioning the what port numbers we'll be using. So Kubernetes service, what it will do means it will manages the network and HTTP requests inside the pod. So this is what service configuration we'll be using for. So in here, I mentioned 80. So this is a port number inside the container, and the target port, it is inside the pod. So this is where the target port will be targeted. So now let us see a few kubectl commands. So in here, I initially started the Minikube. So it takes a few minutes. So I already started and kept. So once it started, we can try out the kubectl commands. So let us say I am already having this deployment YAML file. Now let us try the kubectl command. So first we need to create a pod for this deployment. So for that we will be using kubectl apply command, and with the file tag we will be mentioning the deployment file. So it is the YAML file. We can also use a JSON file for it. So once I mention since I've already built it, it is showing that unchanged. Both the deployment as well as the service configuration, it is showing it is unchanged because I have already done it. And next we can see the what and all nodes are there. So again we are using kubectl command using get, and we will mention the nodes. So initially I am having only the controller plane. So as I said before, in Kubernetes we are having two components. One is the controller plane, control plane, and another one is the worker node. So here I am having only one controller plane. This control plane will take care of all the worker nodes. So now let's see about the what are the paths available. So since I've already built it, if I give kubectl get pods, we're getting the pod. So the application which I the containerist application name is given as my app in the deployment file. So you can see like I've restarted this is now how much time it got restarted. So previously when I run it, it got restarted 7 times. This is the 8th time, and it is already in the running state. Next we can see about the services. So we'll see, for that also we will mention the service name. Once this is done, you can see the service. So there are two services. One is for Kubernetes. So this service is nothing but it will take care of the network management inside the container. So in like for my app, we can mention like near 80. The port number is 80, which I have mentioned in the service file here. So this is what happens in the kubectl. So finally, what we'll do means we'll just deploy it. So it is just a one-line command using the kubectl. We can mention the port forward. Why we are doing port forwarding, or like it is also known as port mapping? So because like in the container, this application will be running on a different port, but in the host system, we have to mention which port we need to run. So for that, we will be using this port forwarding. And we will mention the service also, which is nothing but my app. So that is what I have given the name. And we need to mention the port number in which it will be running. So 5000 is the host port number, and the next one is the service port number, which is 80. So once I do this, we can see it is like it is forwarding it to the 5000 port number. So in localhost, we can see what application has been deployed. So if I type localhost 5000, you can see this is the web application which I built, and this has been deployed in the localhost. So apart from this, this is the like in the command line tool. So if you want to make it an use with an interactive dashboard, means you can use Minikube dashboard. So it is same like as the command line only, but it will be like interactive and be easier for the beginners. So you can see that one also. So once I run the Minikube dashboard command, and the browser will launch the dashboard. So this is the dashboard. So currently I'm running only one deployment, and one in this deployment is running in one pod. And replica. So like we can replicate this application like one or two, like how many number we need, we can replicate it. So let us see the deployments. So this is the only one I have deployed. So this is the app I have deployed. And as I said, it is an interactive tool. In more options, you can like give the scale command. So in Kubernetes, what is the important function, like a feature it offers is like you can scale it. It is mainly used for scalability purpose. So I can mention how many number of replicas I want. You can mention. So for now, I am not mentioning. And there is another like edit command. So as I seen before in the code editor, we have mentioned the YAML file. So the same thing only. So if you want to do some editing, means we can do it here, and we can click update. So this is equivalent to same that using kubectl command, and so we can do it. The same thing only. So this is like an interactive environment. So this is all about Kubernetes dashboard. So now let us come back to the presentation. So that's all about this Kubernetes. So we basically what we have seen means we have seen about the Dockers and containers, and we have seen what is Kubernetes is all about, and why do we need to use this Kubernetes, and finally we have deployed a demo web application with it. Thank you. So if you have any questions, please you can ask now.